Hello guys, today we're doing LeetCode question 695, max area of island. Question is, you're given an n by n binary matrix grid. An island is a group of ones, represented land, connected four directionally, horizontal or vertical. You may assume all four edges of the grid are surrounded by water. The area of an island is the number of cells with a value 1 in the island. Return a maximum area of an island in grid. If there is no island, return 0. So example 1, we have a grid here. I'm not going to read it, it's so many numbers, but the biggest island here is 1, 2, 3, 4, 5, 6. So we will return 6 as the biggest island. The answer is not 11 because the islands must be connected four directionally. Because this one here is not connected horizontally, so it's not connected directionally, four directionally, because four directions is left, right, above, below. This is bottom left. That doesn't count. Input grid equals 0, the output is 0. Okay, the way we're going to do this is a breadth first search. So we're going to loop through the whole grid. Every time we find a 1 value, we check all the surrounding values and then push them into a queue and then check those surrounding values if they are 1 anyway. Let me do that recursively. So let me show you here on the whiteboard. Here we have our grid. Here we have our direction to check all the values surrounding it. And then from here we create a queue. Well, no, actually first we create a function which is supposed to do depth first search. We run the function, breadth first search. We run the function on each time we find a 1. So let's say here our function BFS, this is what it does. Create a queue here, and we set it as the current row and column, because our current row and column is a 1. So we'll just set it as, for now, we'll come across the 1 here, we'll set 0, 0, 0, 0. Then we shift that. And while the queue is not empty, we shift it, So queue is now 1, we shift it, and we get the surrounding values. So for each column, let's say 0, 0, we now check the right value here. The right value is 1. So we push that to a queue, and we increment a count. So we have a count star. So now we set to 1, finding the node. Now we increment it, so now it's 2. And then we push the current position to the queue, so 0, 1 is now in the queue. 0, 0 has been shifted, so now 0, 1 here, 0, 1. Then we check the bottom is 0. Check the left, out of bounds, right is out of bounds. Okay. Then we take the next item in the queue, 0, 1, which is a 1 again. We shift it by getting the position. Then we check the left value is already changed, top value has already been changed, right value has already been changed. If the right value is 0, we don't change it. Bottom values are 1, so we increment the count. Count is now 3, and we push the item in the queue. So now queue has got 1, 1 in the queue. Now we shift the queue, 1, 1. We now check the right value of that. So 0. Check the top value of that, already been changed. Left value is 0, we don't change. Bottom value is a 1. So we increment the count. It's 4. And we push the item in the queue, which is 2, 1. Sorry, 1, 2, 1, yeah, 2, 1. And then we shift the item. Now we've got 2, 1, check the surrounding values. 0, 0, 0, already been checked. By the way, when we find the value, we set it to 0. This way we don't come across it and create an infinite loop. So these will all be zeros now, but it doesn't matter because we have our max count, which is 4. And we set that outside of the breadth first search, so we have a max counter here, which is 4. Then we keep looping through the array, bang, bang, bang. We find another 1 here. So we do the same breadth first search function. Push that into the queue, which is 0 and 5. So we have a counter, which is now 1. We set that to 0. Then we check surrounding values. Right is 0, top out of bounds, left is 0, bottom is 1. So we push that to the queue. So now we have 1 and 5, 1 and 5. So we shift it to get the values. Count is now 2. Then we check the surrounding values. right 0, bottom 0, left 0, top 0. So we finish, we check if the count is bigger than max. It's not, so max remains 4. We can keep looping through the array. There's no more ones, so it won't trigger any more breadth search functions. So we return the max, which is 4. Let me show how it's done in code. Okay, so the first thing we do is we create our directions array, so the position surrounding current node. So 0, 1 is our right one, 0, -1 is our left one, 1, 0 is our bottom one, and -1, 0 is our right one. Sorry, top one. Then we create our max, so the current max, or the max island, biggest island. Then we create our function to do the breadth search, where we pass a row and a column. Then we create a counter to store the current size of the island, and the queue which stores the positions, current position and the position surrounding. So row column is the first position. Then we check while the queue dot length is bigger than 0. First thing we do is we get our position. So let current row and current column is equal to queue.shift, which gets the first value in the queue. Then we increment our count because we found the node, and we set the position. So let's set it at the start here. You want to set here so we set the grid position of current column and current row to 0, so we don't create an infinite loop. If we left it as 1, it will just keep finding a 1 beside it and keep reiterating, which we don't want. Now we loop for each position in the directions array to check the surrounding value. So for let row column is equal to, so for let column of directions, then we get a new column, so a new row, which equals a new row to current row plus row plus row, and new column is equal to current column plus column. Then we check that they're in bounds. As you can see here, you may assume all 4 edges of the grid are surrounded by water. So if it's out of bounds, it's water. So if new row bigger than or equal to 0, we know it's in bounds. If new column is bigger than or equal to 0, we know it's in bounds. If new row is smaller than grid.length, we know it's in bounds. And if new column is smaller than grid 0.length, which is the height, we know it's in bounds. We also have to check if the values are 1, so if the position of new row and new column is equal to 1, we know it's an island. So then we set the current island to a 0, again to stop infinite loop, so grid new row new column is equal to 0. Then we push to the queue our new row, our position, so new row and new column. Then once we've done that, we return the count to return our biggest island. Now, not biggest island, to return the current island. Now we loop through the grid, so let row is equal to 0, then was row smaller than grid.length, then we increment the row, then we do the same for the column, so for let column is equal to 0, so was column is smaller than grid 0.length, column plus plus. And then we check if the current position at the grid, so grid row column is equal to 0, sorry, is equal to 1, we know we found the island, so then we set our max to the max between the current max and the result of our breadth search island search, so row col, and then we return our max. Now let's see if that passes. We'll put equals here, directions equals. Okay, let's run. Again, again for equals. Close property of undefined reading setting. Yep, it's the wrong way around. Current row and current column. Now it should be finished. Perfect. As you can see, it passes. Now let's submit. Perfect. Now the time complexity of this is OM of n, as worst case you loop through the whole grid, and our space complexity is also OM of n, as worst case the queue can store the whole grid, as the whole grid could possibly be an island. Thanks for watching.